our objective is to find the missing side of a right triangle again. We're using this Pythagorean theorem, okay? And like I said yesterday, it's very important. You got to be able to label A, B, and C. Now, what do we call A and B? What's the name of those sides? Do y'all remember? Legs, okay? So again, A and B are next to 90. They're called legs. And then across from 90 is C. The Pythagorean theorem, like we said yesterday, is A squared plus B squared equals C squared. And we need to label those legs A and B. So again, the legs A and B, I want you to put next to the 90-degree angle. So what is A? Okay, so 4, you can put a little A next to 4. Okay, let me give you a warm sheet. Looks like this. You do it every day. We do every day. I want you to do it with it. Okay, thank you. So, what's B going to be here? Okay, so B is not 10 just because there's a number there, right? B is next to 90. So A and then B, we'll call it X because it's missing, right? So I'm going to put an X there, and let's label this stuff. I highly suggest you label first so you don't put it in the wrong spot. If you put them in the wrong spot, it's going to mess you up. Now, C is the last one. It's always across from 90, right? Okay, so can we do Pythagorean theorem? I'm not going to rewrite the theorem. I'm just going to plug stuff in. So A squared plus B squared equals C squared. This is what we all got to know, right? So let's plug stuff in. Instead of A, I'm going to put 4 squared plus B, I'm going to put X squared equals C, which is 10 squared. Okay, this is the hardest thing for some people because X is not always over here. Okay, sometimes you're missing a leg. It goes right there. Now, let's do some math. 4 squared. It's not 8. What's 4 squared? 16. Right? You sure? 16 plus X squared equals, what's 10 squared? 10 times 10. 20? Oh, what is it? I can barely hear you. Oh, okay. You're talking really low, and then it's calling wrong, so it's not 100%. All right, well, anyways. So now I need to solve for X. What's next to X that I need to get rid of? That loner, 16. How do I get rid of a positive 16? Subtraction, minus 16, minus 16. Please remember, if you're missing a leg, you have to subtract. Okay, that makes sense. It's kind of like you're subtracting a leg. Okay, so 100 minus 16 is what? If you don't know, calculator's your friend. 100 minus 16 is 84. So is the answer 84? What do you think? Is the answer 84? Oh, why? That little 2 squared. You can't have a squared. What's the opposite of squared? Square root, okay? Square root gets rid of a square. I'm going to put it on both sides. Square root of X squared, square root of 84. And now, like you were saying, I need to do something with that square root of 84. If you just type it in the calculator and get a decimal, no bueno, okay? I want you to do the factor tree. So, since it's even, let's break it down by 2. Now, if you're running out of room, you can rewrite it off to the side and break it down. 84 is even. So what do I always start with? 2. 2 times 42. Cross out 84. It's even. 2 times 21. Cross it out. 21 is not even. So let's try it. The next prime number is 3. 3 times 7. All right, now, those are my prime factors. I want to circle my pairs. I have one pair of 2, right? Cross one out. And then 2 loners, 3 and 7. So y'all tell me, the circled 2, does that go out, stay in? What do you think? Out, right? Out here. And then the loners, 3 and 7, multiply on the inside. Gives me 21. Cool. So again, I labeled A, B, and C. I put it into the Pythagorean theorem. Solve for X. Reduce the radical if you need to, okay? Now number 2, same idea, a little different. I want to label A, B, and C. What's A? Okay, 6. And what's B? 8. Okay, 6 and 8 because they're next to 90. Leg, 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 right? So A and B. Now, and again, you can switch A and B. It doesn't matter. But C is always across from 90. Okay, what's C going to be? If it's nothing, call it X, okay? Let's write the Pythagorean Theorem. A squared plus B squared equals C squared. So A is 6 squared plus B, which is 8 squared, equals C, which is X squared. Can you square those and add them up? Okay, so 6 squared, 36. 8 squared, 8 times 8 is 64. Okay, now those two numbers are on the same side. I can combine like terms, and I get 100. 36 plus 64 is 100. And like we said before, to get rid of a square, square root. Okay, square root of 100 is what? Now, 100 is a square number. Okay, you could do the factor tree. You get a bunch of pairs, but do we know the square root of 100? What times what is 100? 10 times 10. So we actually already know what it is, hopefully. If not, when you do the factor tree, you're going to end up with a pair of 2, a pair of 5, that's it, which 2 times 5 is 10, okay? So 10 is it. It's actually a whole number. There's no square root because there's no leftovers. There's no loners, okay? Now, that's just kind of a recap of yesterday's beginning of Pythagorean Theorem. Now, today we're going to talk about triples. Okay, this stuff's not that bad, but we're going to be doing some more of this. So stick with me as we go through these notes. The more you pay attention, the sooner we get through it, the sooner we're done with it, right? Thank you for taking less time. Everybody, let's talk about Pythagorean triples. Okay, here we go. Sooner we start, sooner we finish. It says a Pythagorean triple. Pythagorean triples are sets of 3 what kind of numbers? Whole, meaning not a decimal, not a fraction, not a square root. Regular numbers, okay? So if I can get 3 regular numbers to make a right triangle in the Pythagorean theorem, that's a triple. Triples are nice and neat, okay? So we want to find the missing length in each Pythagorean triple below. Show your work in the workbox. I'm going to do the first one, and y'all are going to do the next 3, okay? But let's look at this. Look at each of these columns. The first column is the triangle, okay? But the second column is A. The third column right here is B, and this next column is C, okay? So what I want you to do, given A, B, and C, is label it on your picture. So it says A is 3, so I'm going to put a 3 right here. One of my legs, okay? B, it says, is 4, so put that as your other leg. Remember, legs are next to 90. Now, C is missing, so put an X there. And C is across from 90, so put an X across from 90, okay? Cool. So we got 3, 4, and X. Now, I'm going to do the work off to the side here. Remember, it's A squared plus B squared equals C squared. So I'm going to write 3 squared plus 4 squared equals X squared. I would write small and start at the top because you got to have room to do work in that little box, okay? Probably should have made more room. Anyways, 3 squared is 9. 4 squared is 16. Add them up. 9 plus 16. 25. And then, like we said, to get rid of a square, you square root. What times what is 25? 5. The square root of 25 is 5. So I get, my missing side is 5. So one of my triples is 3, 4, 5. Anytime you see a right triangle with 3 and 4 for the legs, you can already just know 5 is the hypotenuse. Okay? So this helps you out. If you know 3, 4, 5 makes a right triangle, and you see like a 3 and a 5, well, the other one's 4, as long as it's the missing leg, right? Anyways, so I want you to find the next 3 the same way. Label A, B, C, do the work off to the right. I'm going to give you like 10 minutes. I want you to try this, and then we'll go over them here in a second, okay? Let's see if y'all labeled this right. So you see how it says A is blank? That means your A value is an X. Now you might have put it as the other leg, but B is going to be 12, and then C it says is 13. So again, if you have questions on how to label this, you got to know how to label it. It changes the whole way you do the problem, okay? So again, the leg was missing. So now we go over here and we plug it in. X squared plus 12 squared equals 13 squared. If you put equals x squared, that's exactly what I'm trying to get at, okay? Missing legs, A or B, are not C, okay? They're not by themselves on the right side of the equation. At this point, once you set it up, you need to square these numbers. What is 12 squared? What is 13 squared? If you're not sure, calculator will do it for you, okay? Just type it in. 144 and 169. So x squared plus 144 equals 169. Okay, and then we keep going to get x by itself. Does everyone see? Plus 144 has to go. Can't stay on the side with x. So you subtract 144. X squared equals 1. Oh, no, not 1. 25. Last step, to get rid of a square, we square root. Okay, square root of 25. We already did this, is 5, right? Okay. So on this one, my leg is 7. My other leg, B, is missing. So I'm going to put an X there. And then my hypotenuse is 25. All right, and then once again, set it up. A squared plus B squared equals C squared. 7 squared plus X squared equals 25 squared. Okay. And then we square them. We get the numbers. 7 squared is 7 times 7, 49. Now, 25 squared. You may not know that off the top of your head. That's fine. 25 squared is 625. And then to get x by itself, we need to get rid of 49. So minus 49, minus 49. Okay, and we get 576. And then to get rid of a square, we square root both sides. What is the square root of 576? We get 24. So far we have 3 triples. 3, 4, and 5 makes a right triangle with whole numbers. 5, 12, and 13 makes a right triangle with whole numbers. 7, 24, 25 makes a right triangle with whole numbers. Cool. Last one for 8, 15, and C is missing. 8, 15, and then C over here is missing. Okay, that's 8 squared plus 15 squared equals x squared. Square them. Combine like terms, I get 289. And then square root both sides. What is the square root of 289? I get 17. Okay. Now, the front of this notes page, these are your 4 Pythagorean triples. There's more of them, okay? But does everyone see? 3, 4, 5, right triangle with whole numbers. 5, 12, 13, 7, 24, 25, 8, 15, 17, right triangles with whole numbers. Cool? Now, if you got that down, flip it over, okay? I'm going to move it. In a minute. All right, so we're on the back side now. Okay, so on the back it says additional Pythagorean triples can be found, okay, by multiplying each number of the Pythagorean theorem by a constant. So multiplying gives you additional triples. Here's what I mean. 3, 4, 5 is a right triangle. We just learned that. If I multiply all 3 of those numbers by 2, I'd get 6, 8, 10. That's a triple, okay? It's not a different triple, it's just a multiple of 3, 4, 5. Okay, so 6, 8, 10. Okay, so multiples work. Now what if I see something that looks like 3, 4, 5 is a multiple, but I'm missing one, okay? So here's the question. 9, 12, blank. What is it being multiplied by? So we start with 3, 4, 5, and I end up with 9, 12, something. So for 3, how do I get up to 9? What do you multiply by to get from 3 up to 9? 3, right? So fill that blank in. Multiply by 3. So 3 times 3 is 9. 4 times 3 is 12. So how do I get the next one? What? What am I multiplying? Not 10. The original triple is what? 5. 5 times 3 gives me 15. So you take that original triple, find the multiplier, use the multiplier to get the missing side. Here's another example. The only thing I have is 20 for the hypotenuse, but the original is 5. 5 times what is 20? You can do 20 divided by 5, but you get 4, yeah. So if my multiplier is 4, can't I just do 3 times 4 and 4 times 4? Okay, 3 times 4 is 12. 4 times 4 is 16, okay? These are just multiples of a triple, okay? Now, I want you to try some of these with our remaining time. Think of it as a challenge or a puzzle or something. If this was in a video game and it helped you get the cipher to figure out the puzzle to get to the last boss or something, okay? There's your incentive. Okay, but here, seriously, look, here it is, 5, 12, 13. I know 2 of them, and I know it's been multiplied. I'm telling you, these are multiples. So 5 times some number is supposed to give me this 45. So here's what you do. Take the 45, divide it by 5. That'll give you your multiple, your multiplier, okay? So 45 divided by 5 is 9, okay? And if you know the multiplier is 9, can't you use that to figure out the blank one right here? What's the middle one here? 12. 5, 12, 13, right? So if I know the multiplier is multiplying by 9, well, what's 12 times 9? Type it in, get your answer. It's 108, just so you know. Okay? take these three numbers, figure out the multiple, use the multiple to find the blank, okay? I know it can be a little bit tricky. I want you to be challenged. I want you to try that right now, and I'll come around and help you as needed.